Welcome to Filtration Matters, the regular podcast from BOFA International, a world leader in portable fume and dust extraction. In this series, we'll be exploring how innovations in filtration and system design are helping to improve productivity across multiple industry sectors, including in laser, 3D printing, and electronics. BOFA experts talk about how advances in extraction technology are helping to optimize manufacturing processes and product quality, while at the same time contributing to a clean, healthy working environment. Our guest today is Dawn Hartung, a strategic account manager for BOFA Americas with specialist knowledge of additive manufacturing and 3D printing. In this podcast, Dawn will be outlining how continued growth in 3D print markets is driving the development of new functional materials designed for specific applications and products. Welcome, Dawn.
Thank you for having me. It's great to be here.
So before we dive into additive manufacturing and the world of materials technology, perhaps you could tell us something about your role at BOFA.
Absolutely. My role is a strategic account manager with focus on additive manufacturing for the OEMs as well as their distribution partners. I've been involved in additive manufacturing for more than a handful of years, being involved in all types of additive manufacturing technologies, really providing guidance to the end customers with the proper technology and materials that is applicable to their printed parts. So more on the service side, and then while understanding their application. So how that relates back to BOFA is now providing the additive manufacturing OEMs and partners guidance on fume extraction within those systems. Again, understanding the technology materials being used, and then understanding what challenges they are having with their end customers, the end users.
Okay, so most of us are aware of 3D printing, but perhaps you could provide a little bit of market context that explains the rapid expansion of additive manufacturing.
So 3D printing tends to characterize as prototyping or one-off parts, where additive manufacturing is more in reference to industrial 3D printing and more of a production environment. The additive manufacturing environment in regards to industrial side of things, where it moves more into full-on production parts, so functional parts.
Of course, we're not talking about a single process here. What are the most prevalent additive manufacturing processes? How might they differ? And what role does BOFA technology play in enabling these processes?
Sure. So today there are several additive manufacturing processes, with most relatable to BOFA being FFF, FDM, SLA, otherwise known as stereolithography, and material jetting. Filaments, which emit harmful VOCs, volatile organic compounds, which are known to be harmful to human health. So BOFA provides fume extraction for a safe and clean air environment with proprietary carbon-based filters. There are also nanoparticles that come from this process, where BOFA has developed a specific membrane for HEPA filters. Another technology of additive manufacturing is powder bed fusion, which is very relevant in regards to BOFA equipment and systems, where the health of the equipment is very important in regards to print quality. So with powder bed fusion, there's excess dust, there's the powder that could seep into the inner workings of the printer. And so with fume extraction, pulling out that extra dust, it's very important for the health of the equipment for really great print quality.
It seems there's been rapid growth in the additive manufacturing market globally. Why do you think that is?
I believe one of the main reasons is in regards to companies really moving from the prototyping side of additive manufacturing to a full-on production. And so the printer manufacturers and material technology businesses are extending their operations and market offering to support the production of finished parts, notably through processes such as vat polymerization, material extrusion, and powder bed fusion. At the same time, global supply chain issues are focusing on attention on local production capability. So as a result, the investment in 3D printed systems for both products And the facilitating of manufacturing processes, the printing of injection molds, for example, is also up.
Which I guess brings us neatly to the development of the materials that can be printed to make these products. What do we mean by functional materials?
Not that long ago, 3D materials were mostly an ABS-like material or a polycarbonate-like material for prototyping for form and fit. Today, it's all about functionality and real use production parts. So making sure that the precise physical properties, so for example, in metal 3D printed parts, are dense and can really handle the application, and maybe parts being fire retardant or scratch resistant. And so the properties really are an important aspect in regards to moving into production parts and, again, utilizing those functional materials.
Do these new materials create challenges for manufacturers?
From new resins, polymers, and filaments to metal powders, material providers are working closely with the end customers, so the manufacturers, and the 3D print technology providers to develop new formulations fit for purpose. So in regards to that, then that tends to go to increasingly high temperatures for 3D printing environments with these newly developed materials. BOFA research into 3D emissions undertaken by us shows that combining chemical, resins, and powders at high temperatures isn't without challenges. So for example, we now know that temperature in fused filament fabrication, FFF processes, is directly proportional to the volume of emissions and the consequential risk of emissions. In general, the hotter the process, the higher the risk presented by emissions. This is because an increase in 3D printer nozzle temperature decreases the average particulate size generated by the FFF process, which means the particles can be more easily entered into the human body, really potentially impacting negativity on our health. And the gases emitted by FFF printers include volatile organic compounds, the VOCs, which without effective atmosphere management can potentially cause conditions such as headaches, eye irritation, skin problems, occupational asthma.
Tell me something about how BOFA technology is enabling the application of these new materials and helping to filter the emissions out of the process.
Certainly. So BOFA works very closely with 3D print equipment manufacturers, the material providers, and the end users to develop appropriate filtration systems. This involves the application of BOFA's in-house scientific expertise to identify emissions resulting from specific materials and processes, and developing a filtration system specified to help manage the resultant gases, particulates, or fume. So for example, BOFA has redesigned its 3D Print Pro 4 technology to include a more advanced multi-stage gas filtration, including a deeper carbon bed to filter a greater volume of fume. This helps to extend the filter life and to create a safer, odorless print operations. The redesign includes a larger HEPA filter, enabling multiple 3D printers to be hooked up to a single BOFA unit, thereby optimizing investment in filtration technology to support effective atmosphere management and to help prevent buildup of particulate residue within the print chamber. And BOFA has also developed a new 3D Print Pro high temp HT system specifically to meet the growing industry demand for filtration at higher temperatures.
Okay, so finally, let's focus on some of the latest and most interesting products that you've seen that are now being 3D printed using this materials innovation.
There's such a wide variety of products, anything from a home to tennis shoes to spare parts, and just such a wide range of different industries, from aerospace to food and beverage to medical to sports to clothing, even skin cells. So it's amazing all the different types of products that are being 3D printed today. One that comes to mind that is really more for efficiencies as well as weight lighting. And the aerospace industry, for example, in the past, they may have 300 individual CNC machine parts, where now they're able to 3D print this one particular part and also have it not be completely solid. So there's a lot of design capabilities around that, where maybe the inner components it's not a solid heavy piece. And so for aerospace, we know that's very, very important. Just so many really unique different types of products being 3D printed, which is completely changing our world and environment as we know it today.
Thanks, Dawn. Those are great examples of how new generation functional materials are being applied. And more generally, thanks for your expert insights for today's podcast topic.
Thank you, Phil. It's been a pleasure.
Thanks for listening. If you want to find out more about BOFA and the benefits of filtration and fume extraction, visit bofainternational.com, where you'll find lots of sector-specific information. You can also catch up on all our podcast content by visiting bofainternational.com/podcast.